Welcome to Clear Coding. I'm your host, Stephen Clary. Today's video is one of a series of videos that I uploaded to Vimeo almost 10 years ago, which is why I'm going to look completely different for the rest of this video. But this video is kind of exploring how asynchronous code used to look like before async and await what came on the scene. So, hope you enjoyed this blast from the past, and I'll see you on the other side.
Hey there, this is Steve Clary, and today we're taking a look at using events for asynchrony when we also have state, and seeing how that kind of complicates the solution that we had last time. So again, just like last time, I'm going to start with looking at the synchronous version of this. And in this case, we're going to download like a URL that represents like some index data that tells us where this other data is. And then we're going to download all of that other data, the item data or the child data. And then we're going to, in this simple example, we're just going to concatenate all those results. So all those individual items or individual children. And we're going to save that to the database. Save that resulting concatenation of all these different items to the database. So this is a little bit more complicated than what we looked at last time. And let's look at the synchronous version. So I'm going to have a download. In this case, I'm going to pass it a URL. We kind of skipped over that detail last time, but this time we're going to need it. And then when we get the index data back, we're going to have to parse it out. So I'm just going to add in a parse method here. And we're not even going to look at like what this method looks like. This is just an implementation detail. This is just logic. Today we're focusing on what the asynchronous operations look like. And then finally, we're going to save this to the database. Let's save it with the, so here's the index URL that we're saving it as, and we're saving, the concatenation of all those child items as the data. So our implementation is going to look like download and save. We're going to start off with an index URL. And the very first thing we're going to do is download the index data from that URL. And then we're going to parse this out. So I'm going to, making everything explicit here, call this child URLs, and parse out our index data. Oops. And then I'm going to build up our resulting string, which is going to be the concatenation of all that child data. So one at a time, I want to take a look at these child URLs. And I'm going to concatenate, I'm going to download them and concatenate whatever I get back. So there. So now we're building up this concatenation of all the child data. And then finally, when that's all done, after we've downloaded them one at a time, we're going to save them to the database. And that's that. That's our complete synchronous method logic. Again, pretty easy to see what it's doing, pretty easy to maintain, pretty straightforward, right? It just looks like regular code. So let's take a look at what happens in the asynchronous world. So in our download method, we're going to become, again, event-based asynchrony here. So we're going to have that download just start off the download for that URL, and then finally it's going to kick off a download completed event. And the parse method is just going to stay the same. That's just logic. And then the save method, same thing, is going to kick off an event with no data when it completes. So save completed. And what we want to implement here is, just like before, we're going to also trigger our event, staying in the same pattern, download and save completed. And this will become just the beginning of that asynchronous operation. And let's just delete all this because that's just going to get in the way. Right? So the very first thing that we want to do is download that index URL. So the very first thing we have here is download index URL, right? Oh, but it's not the first thing, of course, just like last time, because we also have to say download completed before that. And I'm going to break everything out into separate handlers this time, right from the beginning. I think that'll be easier to see what's going on. So I'm going to call this download index completed handler. And it's going to get a download result. Very similar to what we had last time. So I'm going to say download index completed handler. And then this comes in, and it's the very first thing it's going to do is unregister itself from the handler, because we have we're going to reuse that download method. We're going to now use it for child handlers, and I don't want it all in one handler. Not yet, anyway. Just like last time, the very first thing we have to do is check for errors. So if there's an error, then we're going to trigger our own download and save completed with the download result error. Just pass that right along, and we're done. Otherwise, what we want to do is parse out the data. So this is exactly the same as our synchronous code. We're just going to say child URLs, and we're going to parse the download result.data. So this one line of code is just the same, and this is how this is very common, because even in asynchronous programs, you still have certain pieces of synchronous logic. All right, and those parts still stay the same. They're surrounded by all of this asynchronous mess, to put it nicely. But all this ceremony, all this asynchronous ceremony. But the synchronous parts do actually remain the same. So I'm going to parse out these child URLs using my synchronous logic. That's fine. And then I'm going to have a result here. Let's declare our result variable. And then what I want to do is, one at a time, download these child URLs. So at this point, what I want to do is start downloading the first child URL, unless there aren't any. If there aren't any, then I just want to save. So I kind of have to special case this here. Say if this is empty, then I'm going to, let's see, register, well, we want to save our result and the index URL, which I don't have. Haha. So this is where we start bringing along extra state. So we've got our string index URL. And now I'm going to change this to be like a delegate kind of thing. Download results. And pass along our index URL. All right, so now we're ready to save with our index URL and the result. But before we do that, we have to say save completed and add on our save completed handler. And then we have our own private save completed handler, which takes a save result just like it did with our previous code. And again, we're going to check if we have an error. Once again, manual error handling, great stuff. If there is an error, then we trigger our own download and save completed with the save results error. And we're done. Otherwise, we trigger our download and save completed with nothing, because it's void. So that's our save completed handler. This is always going to be like the last step, so I'm keeping this as a separate save handler. And once we're done here, okay, so of course we also have to return, because this will be, we're done with this. We're done with the child URLs. We're done with our logic at that point until the save completes. Now, if the child URLs are not empty, then we want to start downloading the first child URL. So we're going to say download child URLs, and let's take the first one. And before we do that, we have to say be ready for when the child URL download completes. So at this point, we're going to say download completed. We're going to add in a new handler here. Our download child completed handler. Yes. And this is going to look like download child completed handler. So we're coming in here. This is it's also taking a download result. This is also handling the download completed event, just like our download index completed handler. But we want to take some actions when we've downloaded the index. We want to take other action when we want to take other actions when we download a child. So let's take download result here. And the action that we want to take is to download the next one, if there is one, in that child URLs list. Otherwise, we're ready to save. Well, actually, the first thing, sorry, let me back up there. The first thing we have to do is check for error. So no matter what happens, if we have a download result error, for any of these children, we're going to immediately error out our method. This is the easy way of error handling, right? In fact, just let me copy this up here. And we're good to go. Okay, so we don't have an error. We have data. Now what I want to do is add that data to our result element, or our result string. So we're going to append that on, download result.data, except, of course, we don't have any result here. So what I end up having to do is pass the result so far. You can call that result so far if you want. And I end up having to pass this into my handler. So now I'm changing this back into a delegate where we have download results. Just get rid of those. Into my download result complete. Download child completed handler. Passing in the download result. We're passing our result so far. Okay, so we've appended that data now to that result. And then what I want to do is say, well, if there's another child, right, in that child URLs, then go ahead and access that one. Well, yeah, now we have to pass in that data. So let's take our child URLs, list of string child URLs, and we also need our current index, right? So int index, or maybe the next index. Let's do next index. So this one's the next child to download, right? So here we're going to pass in child URLs, and we're passing in a next index of 1. So when index 0 completes, we want it to continue with index of 1. So we're going to come in here and we're going to say, okay, so if our child URLs are going to be, if the length of those is maybe greater than equal. Don't call me on my off by 1 errors here. So if we're let's handle if we're done. Okay. So if we're done, then we want to save. We want to save the result. So our save completed comes into our save completed handler, and we call save. And we need the index URL in here as well. So string index URL that we need to pass to the save method. And we're going to save that and be done. And also adding our index URL to our Lambda expression there. All right, now if we're not done, then what we want to do is trigger another download. But since this one is already bound to this next index, what we actually have to do is unsubscribe here. So we're going to say download completed. We're going to unsubscribe ourselves. I'm going to assume that your language is going to work with this. Okay. Some languages, that doesn't work. And I'm going to change this so that it's a little bit easier to follow in just a moment. But let's say our download completed now. Oops. We're now going to add it as actually very similar to this, except we're passing our next index plus 1. There. And then we download our child URLs at the next index. All right, so this will do it. This will work. this, unless I've made a mistake somewhere that I don't see here, but all of this asynchronous code spread out over several methods will do the same thing that synchronous code was doing. Now I'm going to simplify this a little bit. I'm going to make it into more of like a component now, okay? So I'm going to add some private data. This can be an object. This can be like a file. You know, in some languages like C, if it could be like a module. You know, if you're more procedurally in a more procedural language, or it can be an object, right? Most of the time these days we're talking objects. So let's say that this whole file, just for simplicity, is going to be an object. I'm not going to write out the class and all that stuff. Just assume that that's there. I'm going to add some private data that we're going to track as part of this. Well, actually, yeah. We're going to add some private data that I'm going to track as part of our object. So first off, we have the index URL, right? We're passing that all over the place. So we're going to add this in. Yeah, actually, that's fine. And we're going to also, what else do we have to pass around here? Our results so far, okay, right? So our result variable, we've got our child URLs, we've got the next index that we're passing that indexes into those child URLs, and finally, no, that's it. Okay. So this is our state, if you will, for that we have to keep track of. We have to pass along from one callback to the next, one event handler to the next, in our event-based asynchronous program. So in this case, since we have this kind of a structure, what we actually end up doing here is saying we want a new object here. At this point, when we call this method, is when we want to create all of this state. This is all scoped to a single call here. So what we want is our new download and save object. We're going to pass in the index URL. And what this is going to do is create a new one of these class. I'm just going to break this out. So here we have, I am going to type out that class. You know what? It's good. Download and save object. And we'll just do that. Right on. Okay. So now all the rest of this is in a class. Okay, so when we new up this object, we're going to pass in this index URL, and our object is going to have an initialize that takes the string index URL that sets this. So our index URL is going to be the index URL that's passed in, and that's it. So if we have our download and save object here, then what we want to do is like call this like start, something like that. This is a pretty common pattern for these kinds of asynchronous objects. So now this is going to move on down into start. Now we've got our void start method coming in, and now we've got all this stuff in our object. So we have all this data in our object. We've got all these private fields, we set index URL, and now the very first thing that we're going to do is kick off, start, and all the rest of this can still work if we clean it up a bit. But before we do that, I actually want to change our object a little bit so that it subscribes to handlers at its constructor. It unsubscribes when it's destroyed in its destructor. Okay, so we're going to change this to be one handler for the download. We're going to change this to be one handler for the save completed. We're not going to subscribe and unsubscribe from those over and over again. So this is also cleaner because it makes sure that all of your stuff is cleaned up. So so this approach is cleaner if you're dealing with asynchronous objects. So here I'm going to say download completed. I'm going to have just a single download completed handler now. And we'll write that in just a moment. And in our cleanup, we're going to have our save completed. Oops, silly me. That's also in our initialize. Save completed handler. We're going to add our handler over here. And when we're all done, we're going to just unsubscribe those. So this cleanup is going to be called when we're all done with this object. All right. And in fact, I don't think our save completed handler was even unsubscribing before, was it? No, it was not. Okay, so we're going to be cleaning up some resource usage as well as part of this refactoring. So we've got this initialize coming in. We're going to just subscribe to the things that we need. We know we're going to need. We set the state initially, and then we clean up. We're going to come back to this setting the state here because there's something else that we need that isn't obvious yet. But it'll become obvious once we start taking a look at this. And then we've got our start method, and actually this here can actually just move right into our initialize. That's fine. We can kick it on off since it's being started right away all the time anyway. That's all we have to do. That simplifies that. I like that better. Okay. So we're coming in. We don't need this download completed handler anymore because we registered them all up here, but we need to write that. So when we come in here, our download completed handler now, which this needs to not take the index URL. That is now part of our class data. And we're not unsubscribing anymore. This is handled in our cleanup function. First thing we're going to do is check if there's an error. If there's an error, then we trigger our own error and return. That's fine. Then we come in here and we parse. Okay, that's fine. I'm going to explain why this actually isn't fine in just a moment. We'll see that. We'll see why this is a problem. But saying we're coming in here, we've got the index data, and then we're going to come down here and say if they're empty, then just save. That's fine. We're not subscribing anymore. Now, otherwise, we need to download a child URL, and in this case, we're not registering this handler anymore. That's all done in the constructor in our initializer. So what I actually want to do here is have this download completed handler handle both index downloads and child downloads. That's what I really want. But there's no way for this one to really know which one it is, unless we keep track of our state. So we're going to come back up here to our state, and the very first thing we're going to add in here is I'm going to call this like an enumeration. Okay, let me think of some symbol here. How about this? So this is our enumeration, downloading index or downloading child. Downloading child. Okay, and this is going to be our state. So now we've got a state that can be set. Let's set this state equals downloading index, right? Downloading index. So that's our current state. Now we can pick up on that here, and we can say, if our state is downloading index, then we want to do all this stuff, right? Otherwise, we want to do this stuff and put the download child completed handler stuff in here. So we're going to do else. Not that. Oh, let's just take the whole thing and then we'll clean it up. So we're going to take this whole handler here and shove it in the else branch. So now this is if our state is downloading index. Otherwise, our state is downloading child. When you're writing out state machines like this kind of comment can be useful on your else branch. Well, let's make it explicit. Then okay, we're not doing the unsubscribing anymore. That's handled in our cleanup. we propagate any errors, and then we take our result, the data, or I'm sorry, we take our download result of the child and we append it to our resulting variable, which is actually not declared up here anymore. I just realized that mistake, right? Because this is now none of these are declared. These are all local data. Now, let's look through this one again. Okay, so we're setting child URLs. Save it. Okay, the rest of that looks good. Okay, so back to this branch. We propagate our error. We append it to the result. We check our child URLs if we're done. Oh, I did miss that too. So our next index here needs to be set to 1, since the first one since it's not actually set before here. So now our next index comes in here. If we're done, we don't subscribe anymore, but we do save and return. And then instead of doing this here, we need to do it here. So plus. So we're going to say next index is next index plus 1. Moving to the next index. And of course, that is not quite right because, yeah, good enough. Okay, so now we've got our download completed handler, which is able to handle index downloads as well as child downloads. And there's some commonality here, in particular our error handling. In this case, we're short-circuiting all of our errors. They immediately go to our own error handler right away, whether we're downloading the index or the child. If that's true for all states in our state machine, we can pull this out before the ifs, right? These are the same. That's not always the case with asynchronous code, but it is the case in this particular example. So now we're done with this child completed handler, and our save completed handler. Actually, save completed is a great place for cleanup. Since we are actually done, this is a nice little place where we know that our object is done at this point, or about to be done once it triggers its event. And I'm going to say that it's safe to clean up here. Okay. Whew, okay. So, all that. Yes. All that. I believe that this is all correct. Again, I'm just writing it out live here. So there's no guarantee. But I believe that this is correct, and this is the standard pattern when you're dealing with event-based asynchronous code, is you end up having to write out an actual object that keeps all of your state. And this is not the easiest thing to debug, right? Let's point out a few problems that we get with a state. First off, we're writing our own state machine. So we actually have like an if statement here. Or this could be a switch, in more complicated state machines. So we actually have, our own custom state machine processing. We have different variables that only are defined at certain points in the state machine. Because we start off with index URL. That's always going to be set. No problem. We can also, or result is also, I'm assuming this initializes to an empty string. So that's also valid, at the beginning. Child URLs is not. We don't even know what this variable, what the value for this piece of state is until we're done with our downloading index part of our state. And similarly here with this next index, it doesn't actually have a meaning at the beginning of our state machine. It's only considered when we're in the downloading child state. So, and think about this. This is an incredibly simple, if you will, still a very simple example. We added some state, sure, but this is still not terribly complicated, right? Once you start talking about retrying on errors and timers going off, influencing your state machine, and just any kind of much more complicated processing that is common in a lot of programming, then you quickly end up with some hideously unmanageable code. This stuff, I would say, is not that great even now, and it can get a lot more complicated very quickly. We still have manual error handling. We still have our logic spread out over multiple methods. This is an illustration. Today's example is an illustration of how the state machine really comes in and super complicates it, even for relatively simple operations. And overall, this kind of code is just bottom line, not very maintainable. So next time we're going to take a look at asynchronous code becoming a little bit more maintainable with continuation passing style, and how that improves on this kind of event-based approach that we took a look at today. We're just going to download a string and save it to the database. We'll see what that looks like in continuation passing style. I hope that you join me, and I'll see you later.